Hi everyone, very good morning to all. Now we are going to study about the question number 65. It's all about the optical instruments. There are three optical instruments: human eye, microscope and telescope. These are the three things we have to understand. So what are the general formula for the magnification produced by a optical instrument we have to remember. So based on that, the questions will come. So let's just try to understand. The very first thing is human eye. See, the very first thing what we have to understand here is when you consider a human eye, so the back layer we call it as retina. When there is an object in front of it, then the rays undergoes refraction at the eye lens and the image forms on the retina. That is called normal human eye. Normal eye without any defect. Now, normal eye which can see up to maximum infinity and minimum or least distance of distinct vision is D, that is approximately 25 centimeter, but it varies from person to person. And here U changes, F changes, but V remains same. So the eye lens has capability to change its focal length. So ability to change focal length, we call it as accommodation. So eye lens has that ability because always image forms on the retina itself. V value is fixed, but F value keep on changes according to the U value. And here, when you consider such human eye, there are two types of question, that is, one defect is myopia, another defect is hypermetropia. So these are the two things we need to understand. Here, the person with this defect cannot see far objects. Suppose up to some maximum distance he can see, like X. So X is the maximum clear vision. He can see up to this distance. Then you have to arrange one concave lens. Concave lens to be arranged such that that focal length is equal to X. So that whatever object is there beyond that X distance, all those will be shifted within the distance X. So then he can see the object clearly. And hypermetropia means can't see near objects. Means beyond Y clear vision, but below some particular distance, like least distance of distinct vision 25, below the 25 we cannot see clearly. Same like for every person, like 100 centimeter or 200 centimeter. So that is called like hypermetropia. Then you have to use convex lens to correct this. And to find the focal length, you have to take the general principle. And here, if they did not mention object, that means it is not able to see the least distinct even. So that you have to take it as 25 centimeter if they don't mention. So accordingly, you can calculate it. Now, what is the magnification produced by simple microscope? So what is the magnification produced by simple microscope? The next device is simple microscope is nothing but a single convex lens. So when object is placed, then the ray will undergo refraction and the image will form like this. So this is the image, this is the object. Then the magnification produced is just like minus V by U. That only minus D into 1 by V plus 1 by F, where D is least distance of distinct vision. And if final image is at D, then magnification is minus of 1 plus d by f. If final image is at infinity, then magnification is minus of d by f because v equal to infinity. So this is like virtual, erect and enlarged image we will get. Just like a simple lens. So simple microscope is nothing but a simple magnifying lens. Then comes combination of lenses. So in case of combination of lens, in case of combination, we get compound microscope. So compound microscope means there are two lenses. One is objective, another one is eyepiece. So objective has focal length f0, eyepiece has focal length fe. But here we will arrange such that here there is one objective and there is one eyepiece. Now objective is always smaller in size, eyepiece is bigger in size. So here when there is an object, this is the first object. Now image formation will happen. Just wait. See here. Now, so this is the intersection point, that is the first image. That is the image of objective and that will act like a object for the eyepiece. Now, that image will form as like virtual. So at a particular distance. So this is the final image. Now the final image is at a distance VE and this is the object for the eyepiece and this is the image for the objective and this is the object for the objective. So that the magnification when you consider just M1, M2, two lenses are in like at a small separation. So that the first magnification M1 is just like minus V by U general formula and M2 is just like simple microscope only. So object is in front of it and virtual image is forming. So that here 1 by, take the same formula just like B into 1 by VE plus 1 by FE. Now if final image is at D least distance, then M will become minus V naught by U naught into 1 plus D by FE. Or if the final image is at infinity, then magnification will become minus V naught by U naught into D by FE. And as F naught is very small, we will take an approximation that V naught by U naught will become approximately L by F naught. So in few questions, you can substitute this in place of V naught by U naught. And the length of the tube L equal to V naught plus UE, that is L naught plus DFE by D plus FE. You can use the lens maker's formula and apply for eyepiece lens. Then 1 by VE minus 1 by UE equal to 1 by FE. Then UE value will become this one. So these are the relations you need to remember regarding the magnification of a microscope, compound microscope. Similarly, when you consider the combination called telescope, so here to cover the large area, large distance, we will arrange the objective of very greater size and eyepiece of smaller size. So that this is F naught, now this is Fe. As object is at infinity, means very long distance, we will consider like infinity, and that image will form somewhere. Now this is, as object is at infinity, now U naught, V naught is equal to F naught. That is the first thing. Now this will act like object for this one. So that undergoes refraction and that final image will form somewhere. So that this is the final image at a distance VE. Now this is the object for the eyepiece that we will take it as UE. So that here when we consider the magnification produced by a telescope, so the general formula is m equal to, there are two cases will come again, minus f naught by fe into 1 plus fe by ve. So that if the final image is at D, then magnification will become minus f naught by fe 1 plus fe by d, and where the length of the tube is f naught plus ue. And if final image is at infinity, then magnification will become minus f naught by fe, where length will become f naught plus fe, and this is called normal adjustment. So based on these formulas, usually they will ask the question. So this is about the three optical instruments, human eye and microscope and telescope. So just remember this complicated formula, then we can solve the question. Let's see few examples. Like the very first question is, a 20 diopter lens is used as magnifier. So the power of the lens they have given as 20 diopter. Then power means 100 by f. So the focal length will become 100 by p. That is 100 by 20. So how much will become? Focal length is 5 centimeter. Now where should the object be placed to obtain maximum angular magnification? Given d equal to d value they have given as 25 centimeter. So the magnification means 1 plus d by f. So 1 plus d is 25 by 5. So 1 plus 5. So the magnification will become 6. It is like a simple microscope. One single convex lens, nothing but a simple microscope. Now the next question is based on compound microscope. A compound microscope has a magnifying power of 100 when the image is formed at infinity. So when final image is at infinity, then the magnification formula is minus v naught by u naught into 1 plus d by, just d by fe. This is the formula. The objective has a focal length. So they have given f naught value as 0.5 centimeter and the tube length L is 6.5 centimeter. Find the focal length of the, and magnifying power also they have given as 100. M value given. D value is 25 centimeter and find the focal length of the eyepiece. Now, see, as they have given tube length, I said approximately we will take the formula L by f naught into d by fe. L is given, d is given, m is given, f naught is given. So fe value will become L d by m f naught. So if you take the magnitude, all the values, so just substitute the values, then you will get the answer. Like L is 6.5, D is 25, magnification is 100 and f naught is 0.5. So this is the way you can solve the question. 25 4s are point cancel, 13 by 4. So depending on the question, you need to choose the formula. As they have given tube length, I have chosen the formula in terms of length of the tube. Now, the next thing, a small telescope has an objective lens of focal length. Objective focal length is 140 centimeter and an eyepiece of focal length 5 centimeter. Now eyepiece focal length is 5 centimeter. What is the magnifying power of the telescope for viewing distant object when normal adjustment? First question is normal adjustment means final image is at infinity. Then the magnification is f naught by fe. Now so f naught, fu, all the values they have given. F naught is 140, fe is 5. So minus 5 to the 8. So 28. So the magnification is how much? 28. Now the final image is formed at the least distance of distinct vision. So this is also again direct question. So m equal to then minus f naught by fe into 1 plus fe by d. So d value they have given as 25 centimeter. Just substitute and then calculate it. So direct formula based. Now the next thing is a small telescope has an objective lens of focal length 144 centimeter and an eyepiece of focal length 6 centimeter. What is the magnifying power of the telescope? What is the separation between the objective and the eyepiece? See here, objective has 144 and eyepiece has 6 centimeter. What is the magnifying power of the telescope? What is the separation between the? See, the magnification power is minus f naught by fe into 1 plus fe by d. Because they did not say the normal adjustment. If they say the normal adjustment, then the formula you have to take accordingly. What is the separation between the objective and eyepiece means? That is the length of the tube. So length of the tube means d plus, f naught plus ue, nothing but f naught plus dfe by d plus fe. So all the values they have given. D value how much? 25 centimeter. F naught given, fe given. So here you have to understand that the separation between objective and eyepiece is nothing but the length of the tube. So you have to choose the formula accordingly. Then you can substitute and get the answer. So do the calculation properly. Now, if a person can see clearly at a distance of 100 centimeter, then find the power of lens used to see object at 40 centimeter. If a person can see clearly at a distance of 100 centimeter, then find the power of a lens used to see the object at 40 centimeter. So here when you consider the object is at a distance 40 centimeter and he can see 100 centimeter clear means the object should be shifted to at 100 centimeter. Then you have to find the corresponding focal length. That means what kind of defect it is? Hypermetropia, because he is not able to see the near objects. So then you will take the formula 1 by v minus 1 by u equal to 1 by f. So 1 by v is 100, minus 100 minus 1 by minus 40. So it is nothing but 1 by 40 minus 1 by 100. So f value is 100 into 40 by 100 minus 40, 60. 2 to the 2 3s are. So 200 by 3. So this way you need to understand the question whether it is hypermetropia or myopia. Then you have to solve the question. If it is like myopia based question, the question will be very easy because you have to find what maximum distance you can see clearly, so that the focal length of concave lens will become just f equal to minus h. Or they can ask what is the power of the lens to be used. So this is how you can solve the questions based on the optical instruments, and similar questions I have given as an assignment. So just try to solve all the questions. And I have given the NCERT questions also. See, lot of questions they have given based on this. So please try to solve all the questions. So thank you. We'll continue in the next session with the next question.